Hello everyone. I just thought I would do this really quick. I was just creeping around on Google Earth and I found this. I'll zoom out eventually for context so you can see where this is. It is in the Upper Peninsula of Michigan, but I just happened to see this and I was like, oh, cool. And there is a photo there. Now, what's cool about this whole area has not had a lot of geologic study done. It's near the Huron Mountains, in the Huron Mountains, which is between Marquette and the Keweenaw Peninsula. Now, I don't really know why that is. Some of it has to do, I'm sure, with the Huron Mountain Club, which is this creepy rich people club near the shore of Lake Superior to the north. But this is not in that area. This is an actual preserve. You can get to this. Now, the cool thing about this is you look at this escarpment, and even on Google Earth, I can tell this thing is massive. Now, you can't really rely on the elevation to really do anything because that's not that accurate. But you could be looking at cliffs here up to 50 feet high. And it goes around and kind of peters out right here, and then boom, look at this. This is just massive, and it's all visible from this ATV road. And over here, you could be looking at near 100 feet. Now, this is odd for just an escarpment. This seems to end right about here, or at least peter out. And I think it's more because the landscape just rises. But what would cause something like this? What do you guys think would cause something like this? Faulting is one of those things. Well, I want to show you Mount Erevan is not that far away. Where can see if I can see it. Mount Erevan is a Archean outlier that's believed to have been upthrusted. I personally, oh yeah, there it is. Yeah, right there. Okay. And you can see the distances. How far are these two? The summit. Sorry, we're doing it imperial. I'll change it to kilometers for everybody. So 92 miles, but that's as a crow flies. So kilometer-wise, you're looking at 3K. Okay? So it's not that far from this. So we look at it here and we get this valley. This valley in here. Something significant has to happen here. At least geologically significant. Now, as I said, I know this is Archean. I don't know about this for sure, but I suspect this is something because this escarpment does continue on and on and on. And I do plan on going out here. Now, geologically, like I said, this area isn't really well studied, and I want to go visit Quartzite Falls too, which I actually don't see how it could be quartzite unless it's something called the Goodrich Formation. But there's no real good geologic maps of this entire area. All right? They just don't exist. They're just not here. This is probably the best one for in context. Okay, you can see up here, this is populated, this little peninsula here, because it's cute and pretty, but nothing's out here. There's no houses, nothing like that. This map calls it the Baraga State Forest. Now, we have XS here, and we have, it's AG, I'm pretty sure it's AG, over here. We also have AG here. So what are these two things? Well, I can tell you what AG is, but we'll go from top to bottom. We'll go to XS. Stratified rocks, unconformably on Archean crystalline rocks. Sedimentary rocks is the S, V is the theolitic submarine volcanic rocks. Basically what this is your Pinokian orogenic part of deposits that were really on the Superior Continent. They were really right there on that shoreline, if not on shore. Okay, so this would be your Michigami Formation, your Goodrich Quartzite, the little interbedding lavas, the ones below it, whatever. Okay, and now we look up or down, we go to AG. Schists derived from AGS. Okay, metavolcanics, metasedimentary rocks, deformed, metamorphomed shortly after deposition. That would probably be those late Archean granites. It's not the Paleoproterozoic Huronian group. And that's what it is. So we come back here, and you see it says XM here. That's probably actually Michigami. Yeah. Oh, no, mafic intrusive rocks. I was wrong. So this is Michigami, Goodrich. I believe that's the Barragood group, if I remember correctly. But, so now we come back over here, and you look, and we got to try to figure out where we are. This map is poor, and these big lines are faults, and they're just drawn randomly. I'm not going to say much, but the author of this map was somebody I know. He's old now. This is who it does, and I'm not going to, but let's just say he's not the best guy at fault interpretation and fold interpretation, okay? Just going to leave it at that, but it generally, for a general use map, it's not bad, okay? Now, so we have two faults bounded here. I've never been over here. I don't know if you even need faults here. My suspicion is you don't. That seems to be status quo. Canon tends to put faults randomly in places that are kinematically impossible, like everything down here. But we are about, if you look at the map, between here, rock cut, and then we have, where is it? Where are you? It disappeared. Well, Mount Kerwood's down here, and Erevan. It's between these two. And a lot closer to Erevan. I can't really tell from this map exactly where it is, but I think we are looking, there's rock cut. We got this here, summit of Mount Erevan. Mount Erevan's pretty big, but the fact that we know it's 3 miles, our scale, or 3 kilometers, sorry, our scale down here, where are you? It's probably in the middle. These are usually in the middle. No, it is. Oh, here we are. Yes, it is. Okay, so 5 kilometers is about my 3 fingers. Okay, so 2 of my fingers are roughly 3 kilometers. All right, so we're going to go back up here and just roughly get our position. Oh, that's where I want to be, over here. You can't see me do this, but I am doing this. Mount Kerwood and 2 fingers. It puts me right in here, which makes sense because topographically, you look here and you see this and this, but it's not as smooth as they have it on the map. On the map, because this is a small scale map, covers a large area, it's not as defined. The topo lines are not as defined, but we're probably right over here somewhere, or right the Kerwood. We could be up over here. This might totally be Michigami slate, okay? I don't know. This could be Goodrich quartzite. I don't know. It could be the Archean bedrock. Now, I had the feeling that there's a couple of things going on here. I need to get over there so bad. Obviously, it's late February. I'm not going over there tomorrow. And these roads are not open. But just this drastic change. The Michigami tends to weather pretty easily when juxtapositioned against hard Archean granitoids and against Huronian or Paleoproterozoic quartzites and stuff like that. Now the thing is, I think this is called Quartzite Falls. Now, just because it's called Quartzite Falls doesn't mean it's, where is it? Doesn't mean there's quartzite there. Where is it? Is it up here? It's up here somewhere. But anyway, I'm going to go there. That might actually be quartzite. It might be the Goodrich. The Goodrich is not a true quartzite. It's quartzites or sandites, metamorphic. It's got more lithics in it and more feldspar in it. It's not a true quartzite, but the metamorphic name for it is just sandite in general. But yeah, so I'm really interested in this, and I really want to go out here and I want to walk through here. It's probably a good cut from this valley. That's what it looks like. And then you get here, and it's probably just trees. But the fact that this runs straight like this and becomes this creek, an almost perfectly straight line for a long distance, makes me think this is structurally controlled. Now you look at this map here, and that would be, somewhere over here, okay? Somewhere over here in this line, and we have Cannon's faults here, but they don't run the right way. They go northeast-ish, and this thing is clearly more north-south, or, and then Banks slightly northwest. But I mean, it is slightly northeast, but not to that drastic that Cannon hasn't mapped. But I do have the feeling that this valley holds something interesting. This over here is probably lumberjacks cutting stuff down, or it could be a storm. But as you can see, there's no one here. No one lives here. Okay, this is all forest and timberland. Some not lumberjacks, some foresting companies do own some of this land. They don't care that you go on their land. They just don't want just taking anything from it. Which, a little rock here and there's no big deal, but they basically don't want you going in there removing half their trees. So, yeah, you can see this thing is long. It is so long. Now, could this be a single structurally controlled tributary? Of course, but it's probably not. It's probably two. It probably cuts over. Now, I do not know the fracture trend here. This may just be fracture controlled. But it could be north-south, and it could be, usually fractures are perpendicular to each other, and I kind of get that feeling that there's a lot of fracture controlled tributaries here, because this one's exceptionally straight, okay, along its stretches before it bends. Most are not, but you definitely get this trend, this trend, this trend. You get these 90-degree trends you tend to get in these type of rocks. So even this is kind of, this is not a true dendritic system. It looks more controlled by fractures. You got northeast and you got northwest, and those seem to be your primary fracture trends, at least at this scale. So if this is structurally controlled, maybe it's not fracture controlled. Maybe something else is going on here. Now we look at this, and what do we see? We see to the south a little bit. Oop, I hate that. We see this. Is this a syncline? Mapped as a syncline? Yes, that's a symbol for syncline, two arrows going towards the axis here. So we have some sort of syncline here, but that's not the kind of structural control that is going to form something like this. Okay, so I think that's it. I just got really excited, and I thought I'd share it with you guys. But anyway, I think that's it. If you have any questions or comments, please leave them below, and I hope you learned something.